some of the feedback I was getting was that the programming was taking what seemed to be an inordinate amount of time, which was not something that I want. And what I'm trying to get across with this is just if you have an event graph in hand and want to turn it into a SimKit program, then it's just a matter of identifying the pieces in the event graph and then translating them into the code. And it's been set up to be a fairly straightforward process, at least in my mind. As they say, sometimes your mileage may vary. But hopefully, I mean, if you follow the way that I've been doing it so far and use this kind of step-by-step process that I've been sort of talking about, then that, in my experience, results in an overall shorter time to get from a blank, from sort of nothing to a working program. In other words, the fastest way to get your code working is not to write the code fast, but to write the code slowly. That's the fastest way to get a working program. And that's true in what we're doing here. And that's true in general. That's true regardless of what you're programming in. It's not a Java thing. It's not even a SimKit thing. It's just a programming thing. Again, if you write a lot of code and then expect it to run, that just doesn't happen. If you write a little bit of code and then test it and make sure that it's working correctly before you move on, I mean, that may seem excruciating. It may seem like you're, just moving too slowly. However, what causes things to take a long time are not that it takes a long time to write the code, it's because it takes a long time to get the code working correctly. And so the fast, again, I can't say this enough, the fastest way to get a program working is to go slowly and to write a little bit of code and test it. And at each step, ask yourself, how do I know that what I've just written is going to work? And if you wait until there's a pile of code and it doesn't work, then it's looking for a needle in a haystack, and then you start sort of flailing around. And when I say you, I mean me. I mean, this is everything I'm telling you are things that I have done. And so it's not that I'm sitting here telling you, oh, this is the way it should be done from an ivory tower. I'm telling you because of my experience in the trenches, as it were. So, okay, so before I start, I mean, I am planning on sort of taking that model to completion, because sometimes what the implementation can do is identify potential issues in the event graph itself. That is, all of this is assuming that the event graph is correct. But how do you know the event graph is correct? I mean, that's again another another issue. And so, I mean, I mean, I don't want to, it's going to take a bit of time and it's going to take away from some of the other things that I'm going to do. But however, I think that it's important that you try to get this, because I don't want you to be wasting a lot of time on the programming. I want you to be spending a certain amount of time, which in my view is constructive in the programming. However, if you're spending inordinate amounts of time in the programming, that is counterproductive to what the goals of everything is. So that's what this is all about.
Hey, sir, if we have time today, can we go over something close to like question number 2 for the homework that's due today?
Okay, maybe toward the end of our second session today.
Okay, thank you.
Okay, so this is section 8 in the handout, and this is something that is very useful. If you really kind of follow this, then this has almost all of the information that you need in turning an event graph into a working program. So the simulation component, again, like an event graph, can either be a full event graph, as in the example I'm about to do, or it can just be a component. But that is the corresponding thing is a subclass of SimEntity base. The parameters are private instance variables with a setter and a getter, and the state variables are protected with a getter but no setter. And the reason for that is that's how SimKit figures out whether something is a parameter or a state variable. I mean, there's no magic to that. It just says, okay, if I see something that has a setter and a getter, then it means it's a parameter. So if you accidentally put a setter in addition to a getter on a state variable, SimKit will think it's a parameter. Now that's not the worst thing in the world. It just can be a little confusing. That's all. Every event in the event graph corresponds with a method of the same name, but with this do in front of it. That's just a way to know whether a method is a regular method or a method that corresponds with an event. The scheduling edge is a call to wait delay inside that do method, with the run event being done specially because it has two methods. Its reset method initializes state variables, and the do run typically will fire property changes and also schedule events. So if I schedule an event from the run, then it's a wait delay in the do run. If I schedule if I have a scheduling edge from any event, then it's a wait delay in that corresponding do method. If I cancel an event, you've seen one example of this, that's a call to interrupt from the canceling edges do method. So now the priorities, if a priority is present, it's put in as the third argument, and there's the built-in ones are, well, if you don't put one in, there's a default one. If you want higher priority, there's high, higher, and highest. You should generally avoid the highest. And then there's low, lower, and lowest, and you should probably avoid the lowest one because it just, those are for some internal things. If you have an argument, then you add that as the last argument in the wait, or the argument is an argument in the corresponding do method, whereas the parameter that you pass is the last set of arguments, parameters in the call. And then likewise, a canceling edge would be a call to interrupt. Okay, so this is basically a Rosetta Stone that translates event graphs into SimKit models. Now, what we've been implementing is this event graph, which was the second problem in the previous assignment. And the issue had to do with this self-scheduling edge. And hopefully, well, I don't know how convincing these numbers are here. The lesson there is that when you're looking at an event graph, when you're trying to write an event graph and you want to know, okay, how is it working? One way to just sort of test it out is to put in some numbers for the various parameters and state variables, as we did here, and then verify that the right things are happening. And that's kind of what we did here to show why this scheduling edge was necessary. So to that end, we implemented that as a class, multiple server batch arrivals. We extend SimEntity base. We had our parameters. We had 4 parameters. Now, generally, if we have a sequence of things, they are either a random variate or a discrete random variate, as it was in the case of the batch. And so we had a random variate for the inter-arrival times, the int for the number of servers, a random variate for the service times, and then a discrete random variate for the batch generator. Again, I hadn't mentioned what a discrete random variate was yet, and so I mean you're not responsible yet for using one of those, but that's something that would come up with this. Then for those, we had setters and getters that were generated, and now for some, if you have a parameter that requires, that has constraints, such as in this case, the total number of servers had better be positive. And if you try to put a non-positive one in, then you get a complaint. And that's actually something that you do want to kind of test. Okay, then we generate getters for our 2 state variables that are protected. Then we typically write 2 constructors. One is a 0 argument constructor, and then the second is one that has all of the parameters and then sets them. Then to implement the run method, so again, what you do on this is a convenient way is, well, I'll usually have this printed out as a hard copy, sort of sitting there. So I look at the run event. And the run event is the one special one because these initializations are implemented in the reset method. That's right here. We always call the super reset first, but then where did this come from? Where did these 2 expressions come from? They came directly from the run event. Q is 0, S is equal to K. Number in Q is 0, number of available servers is the total number of servers. And you can either use the getter here, or you can just, if you wanted to just do that, that's perfectly fine, either way. Then the do run method for all the state variables, you fire a property change there in the run. Everywhere else, whenever there's a state transition, you fire the property change right after you make the state transition. In this case, question.
Yeah, just to be clear on that, when you fire the property change, you're now creating an object called number in queue and number available servers, correct?
No.
No.
No, number in queue. Okay, what is number in queue? Number in queue is an integer. What you're doing is you're actually creating what's called a property change event. When you fire the property change, you're creating a separate object called a property change event. And all it's doing, it's like, remember action events from when we were doing swing? It's like an action event. It's something that's created underneath, under the hood, and it just gets dispatched to anybody who's listening. Just as, you never created an action event. The action event was created for you when you clicked on a button, and it was sent to all of the action listeners that were listening to that button. The same thing is happening here. When you fire a property change event gets fired to everybody who's listening. Now, who could be listening? in this case, when we're testing it, this thing called a simple property dumper is a property change listener. And how do we tell the server that we want to listen to it? We say add property change listener and pass the instance of the property change listener that we want to have listen to it. This is exactly like what we did with buttons and action listeners. So the action listener had things that dealt with the action events, but we never created those. Likewise, the property change event is something that gets created under the hood and sent off to anybody who's listening. Okay, does that clarify it?
Sort of, I think I got it.
Yeah, see the number in queue, what is that? That's an integer. Number of
Yeah,
available servers, that's an integer.
Those I get. I mean, those are easy. It was just kind of the conceptualization of firing the number in queue with the get number in queue.
Yeah, yeah. And again, now I here I recommend using the getter whenever you're firing the property change. That's but you know, that's not terribly hard and fast. It's just I found it to be more, I just found it to work out better. Okay, so the run event, again, we're ignoring everything else and we're focusing just on this one event. Okay, so what's there? What is an event? There are always only two things, or sometimes three in an event. There's a state transition, and there's a scheduling edge, and sometimes there's a canceling edge. So there are either two or three things, and sometimes there's only a state transition, and no scheduling, and sometimes there's just a scheduling and no state transition. You know, so regardless of what's there, you implement what the event graph is saying. So here it says we schedule an arrival with a delay of TA. And what is TA? That was the inter-arrival times. So in the run, we say wait delay arrival. See that name, the name arrival comes from the fact that we are pointing to an arrival event. And the second argument is now the wait delay method is heavily overloaded. So we can either give it a number here or we can give it a random variate. So it will accept either one. What it does under the hood, if you give it a random variate, what it does is it invokes the generate method. This was just to save a little bit of typing, really. If we write this generate, that's just as good. That's exactly what happens. Okay, so now what we have done, and just as a check, here's the run event. We have the initializations, which we did in the reset method, and then we scheduled an arrival, which we did with this wait delay. Now, before writing another line of code, what we want to do is we want to test it out. And the way to test it out, once we start doing our events, is the best way is to do it one event at a time. So, and what do we want to verify? We want to verify that the right state changes are occurring. And we do that with the simple property dumper. And we want to make sure that the right events are being scheduled. And we do that by setting verbose mode on schedule. And so when we run this now, and again, I'm not all I'm expecting. I just have the run event scheduled. So what is it I'm looking for? Again, you want to have in your mind what you expect to see. So what I expect to see is I expect to see the run event. I expect to see the run event scheduled, and then it will schedule the arrival event as well, but then nothing is going to happen because I haven't written the arrival event. So that's what I want to, that's what I'm expecting to happen. And so I take a look at that first. Okay, so first I verify again that I haven't lost any parameters. That's why you do the print line of the simple of the object, is verify that all of the parameters have been correctly set. Then, okay, here's the run event. Number in queue is 0. The number available servers is 5. Now remember, see, our total number of servers are 5. The number of available servers should be the same. Okay, so all that check. And then it's scheduled the arrival event sometime later. Okay, so if somehow this were 0 or is this the right number? I don't know. But at least it's a positive number, and so it should be the right one. And then when arrival happens, I'm not expecting anything. So the fact that I didn't see anything is no big deal. Okay, so now I can say I have correctly implemented the run event, and so I can put a check on that and then move on to my arrival event. Now my arrival, I want to do the same thing. I'm just going to implement one event, this one arrival event. So what is an event? An event becomes a do method. So now I want to write back here. Now I want to write my do arrival. Okay, so that's how I write the event. And then what does the event do? Well, first I do the state transition. Now the state transition here, it's a little bit different than the one that we've had before, because we have a batch arrival. So the number in the queue is going to increase by B, which is going to be, again, what is B? B was that sequence, and that sequence we have implemented as our, where is it? Our discrete random variate. Okay, so so let's do that. Now for these time varying ones, we have the old value. We get the old value now. Then the state transition is we increment by the batch. So now, so here's how we do that. It's generate int is the call. Again, I haven't taught you the discrete random variate yet, but that's generate int, I think, is a fairly well named one. And then again, every time after the run method, every time we make a state transition, we fire a property change. So the property change is number in queue. And we send for the time varying ones, we send the old value and the new value. And then, okay, what else is going on here? Well, we have a self-scheduling edge to the next arrival with a delay of our inter-arrival times. So what is that? That's a wait delay arrival. Your inter-arrival time generator. Okay, so that's that. Okay, are we done? Okay, we've done the state transition. We've done this scheduling edge, but we have another one. And what's the condition? If S is bigger than 0, that is if we have an arrival and there's an available server, then I want to schedule a start service. And there's no time on this, which means that it's going to be 0. And there's also this little h, which says it's going to have high priority. So let's do that. So the Boolean condition is we wrap in an if statement. So if the number of available servers is bigger than 0, then we will wait delay start service. Okay, the first argument is the name of the event. The second is the delay. And then the third is the high priority. And we can say hi, and then it can't find the symbol, and we can add the import for the high priority there. And the high priority is, it's it's kind of a just in case type of thing. All right, so I've implemented one more event, and what I want to do now is I want to test it. Now if I just kind of do the test, I'm gonna have a kind of a runaway here. So, but that's okay. I'll show you what that's like. Okay, so now we have a you see how it's running away, and I was expecting that. Okay, why is it running away? And again, the way to stop it in NetBeans is to sort of hit this little red stop thing. It was running away because I didn't tell it. I didn't tell it how to stop. So let's this is helpful. Let's run it for 20 time units. Okay, so now, all right, now what am I looking for here? What I'm looking for is that whenever arrival happens, it should schedule a start service. And it will always do that because the number of available servers is never going to decrease in this yet. All right, and so the queue is just going to build up. So let's verify that. All right, so again, it never hurts to just double check everything we've done before. Are the parameters there? Check. Is the run event happening correctly and scheduling arrival? Check. Now we have the stop event. Is that at the right time? Yes. Okay, so check. Right now here we have an arrival. What are we expecting? We're expecting the number in the queue to increase. Now notice that since our batch generator was discrete uniform, the increase in queue is always going to be at least 2. It's always going to be 2, 3, or 4. Okay, so we have an arrival. The number in the queue jumps from 0 to 4. So that shows us that at least we're getting, we could be getting the right numbers from that. And we schedule a start service because, why? Because the number of available servers is 5. That's still bigger than 0. So we schedule a start service. Now, start service we have not implemented, so I'm not expecting to see anything here. But my arrival scheduled a start service, and then it scheduled another arrival sometime later. What are the things that could go wrong here? Well, I might have scheduled the arrival with a delay of 0, and that would show that this time would be the same as this time. So you notice that the start service is exactly the same time as the arrival here, which is because there was a 0 delay. So start service occurs. We haven't implemented anything about it, so nothing happens. But then every time we get an arrival, so here's another arrival, we jump by 2. There's a start service that does nothing. Here we get another arrival, jumps by 4 again. Another start service, we jump by 2. We jump by 2. Here we're jumping by 4. Okay, so and then here we get a jump by 3. So what we are verifying is that the arrival event, as indicated here, is scheduling itself, and it's also scheduling start service always because S is bigger than 0. So now we haven't, because we haven't implemented start service yet, we still need to verify that this condition is correctly being implemented, but we need to implement start service before we do that. Okay, so but we've more or less verified that the arrival event is correct. So we're ready to move on to start service. And just by the way, sometimes if you're also a little bit, it can sometimes be helpful to do a commit if you want. But Okay, so here's start service. What are we looking for in start service? We have our state transitions, which are the Q, decrement Q by 1, decrement S by 1. Okay, so that's, we've done all this before. Now, you notice that one of the things that I'm doing is I'm also typing everything out. Now, sometimes it can go a little faster if you do copy and paste. At this point, I would strongly encourage you to still type everything out, because as you type everything out, I'm not sure why this works, but for some reason, the more you actually sort of type things out instead of doing a lot of copying and pasting, the more this kind of it just gets, you just kind of absorb it. That's been my experience, but I can't force you to do anything. I'm just suggesting. Okay, so state transition, we have 2 state transitions. Let's just verify that we are on board with that. So Q, S, okay, check. Now let's look at our scheduling edges. So one of the things that I want to illustrate is what happens if I don't put this scheduling edge in here. Okay, now in our multiple server queue, though, we had this schedule of end service. So let's put that in. Well, oops. Now, this is case sensitive, so we want to make sure we don't fat finger these strings. So service time generator. Well, I'll do it. I'll do it the correct way first, and then we'll see what happens when it doesn't not done. Okay, so that's this scheduling edge. Now we have a self-scheduling edge. Okay, and what's the condition? The condition is Q bigger than 0 and S bigger than 0. Okay, what's that about? That means that as every server is serving the customers who've shown up, we keep doing that until we either run out of servers or we run out of customers in the queue. So, so if the number in Q is bigger than 0 and number of available servers is bigger than 0, then we schedule our start service again. Now with a 0 and a high argument. Okay, so let's see what is going on with that. Okay, now what I'm expecting to see, if you remember, let's kind of look back here. Our first arrive, we had 4 customers arrive. And so what I want to see is I want to see 4 start services after this start service. I want to see the state transition. And I want to see after this first arrival, okay, and this is where it's helpful to look at the numbers. So at this point, I have 5 available servers because that's where I'm starting with. I got 4 customers showing up. So at the end of this first arrival, and after the start services have finished spinning, I want to see none in the queue and 1 available server. Okay, that's what I'm looking for. And then the second arrival, now it's probably not going to happen at the same time because, but when that second arrival happens, then there will only be one available server. So after that, I want to see no available servers, but then if there are two, there should be one left in the queue. Okay, so let's see if that works. Okay, so it's running away with our end services. And why is that? Ah, that is because, all right, so that's a valuable thing. That's because I fat fingered my state transition here. And I can tell you that right here, because look at what happens at my start service. My number in queue all of a sudden goes from 4 to 5, and my number of available servers goes from 5 to 6. So what happened? Well, I put a plus instead of a minus. That's what happened. Okay, so this is how you identify mistakes that you make. That's why running it in verbose mode with only, if I'd waited until I'd written that last event, then it would be hard to tell what happened. So, okay, so now I should expect something a little more reasonable. Okay, so let's remember what I said I was looking for. Okay, here's our first arrival. We still have, now there are 4 in the queue. Okay, so here's the first start service. Number in queue goes from 4 to 3, number of available servers 5 to 4. There's another start service scheduled at the same time. That start service occurs. Now number in queue goes from 3 to 2, number of available servers 4 to 3. Another start service because there's 2 in the queue, 3 available servers. Another start service. Now there's 1 in the queue, 2 available servers. Finally, none in the queue and 1 available server. And now no start services scheduled, but now we have 4 end service events scheduled and the next arrival. And now what I'm also looking for is on the next arrival. Now the number in the queue is 2. There is 1 available server. So it schedules a start service. That start service occurs. Number in queue goes from 2 to 1. Number of available servers goes from 1 to 0. We've run out of servers and now there's no start service. Okay, now at this point, now the end service events are just going to be happening, and I wasn't expecting anything like that. So the queue is just going to keep building up at this point, but that's what I would expect. Because why? Well, because I've taken away the servers, but I haven't put them back. All right, so we've implemented all of the events except for this end service event. All right, so let's finish it up. Now, what does the end service event do? It increments our number in queue, or a number of available servers. Okay, so now we increment it. We still fire our property change, so we know what's happening. Okay, so that's the only state transition we have. If remember, in some of the other implementations, we had other state transitions there. That's, we would do that if it was there. And then now we have one scheduling edge that says if there's a customer in the queue, we'll schedule a start service with high priority. So better the if number in queue is bigger than 0, we schedule a start service with a delay of 0 and high priority. Okay, so now I'm looking for the, for things where after the end service, if there's somebody in the queue, I want to schedule the start service. And oh, by the way, in the previous one, we had also verified that arrival, that this condition on the arrival to start service scheduling edge was working, because there was an arrival with no available servers and it did not schedule start service. Okay, so now at this point, what I'm looking for is basically the full thing. And again, I want to go through everything. Have I lost the parameters? Because again, it's just too easy to accidentally delete something, right? Parameters are all still there. The run event is still there. Okay, here's our arrival. And then here's where our start service spinning down to 1. And here's the next arrival, spinning our number of available servers to 0, but leaving 1 in the queue. Okay, but now we have an end service event. And that end service event is, there is a customer in the queue. So we have 1 available server. We schedule an end service event, or the end service event occurs, that schedules a start service event in that case. Okay, so now the number in the queue is 0. We have no available servers. The next end service that occurs, we now have 1 available server, but there's nobody in the queue, so it does not schedule a start service. We have another end service event, and we now have 2 available servers, but there's still nobody in the queue, so it does not schedule a start service. Now we have an arrival. Okay, so now we are in a situation, we have 2 available servers. We have 4 customers arriving. And so what should be the result after the start service events keep spinning? There should be nobody, there should be 2 in the queue and no available servers. So let's verify that that happens. So first, here's our first start service. Number in queue goes from 4 to 3. Number of servers go from 2 to 1, and it schedules another start service. Then number in queue goes from 3 to 2. Number of available servers 1 to 0, does not schedule another start service. Okay, and then we have another, et cetera. So what we have done is we have verified that, you know, to the best that we can, that we have correctly implemented this event graph. Okay. Now, at this point, of course, what you want to do is you want to comment everything. I won't do that here. I will comment things and then commit them after the class. But okay, so now are there any questions about what I've just done? Any? And again, this, like what I'm saying is that if you follow what the process that I just did with every implementation of an event graph in SimKit that you did, then it will go much more smoothly, and you have a much better chance of getting a correct model, a correct implementation, and a much better chance of not spending inordinate amounts of time trying to debug your program. Because you notice that when, for example, here on the start service where I accidentally put the wrong state transition in, it was immediately apparent. And when I got that runaway model, because I was plussing instead of minusing, it was immediately apparent, and the place to look was what did I just do? What I just did was the start service event. So I knew exactly where to look, and I knew exactly where the potential problem was. And I knew that there was a problem because it was immediately showing up. Okay. All right, so now we're ready to begin today's class. I have enough time to talk a little bit about, again, about these adapter things. And then I'm going to show another way of implementing a tandem queue using only the multiple server queue, the simple server components that we had, and I asked you to implement a couple of times ago. And then there are two models that I want to look at where, again, we're tweaking our basic multiple server queue framework. One in which we have two types of customers, but only one server, but the server prefers one type of customer over the other. And then another situation, which sometimes comes up, where we have two types of customers, but then one requires a single server and the other requires two servers. So how do we handle that situation? And that turns out to introduce a lot of complexities. So, okay, so and one of the useful things that we have to deal with that is something called an adapter. And we've seen an adapter before, and it's useful to just revisit it. So an adapter is like a sim event listener, but it's for a single method. And what it does is it converts the name of an event in the source to a different name in the listener. The notation looks like this. So the idea here, and this is just kind of abstract, the idea is that we have an event B here, and we want this event B to trigger this event C in this other component. So we have these two components, and we want this event B to trigger the event C. Now notice that none of them have arguments, and that's one of the requirements, that the arguments have to be the same. So if there's no argument here, then there has to be no argument here. If there's an argument here, then it will work just as well, but there has to be an argument in the other event as well. Okay, so it's similar to the listening, the sim event listening connection, which has just a single line. This has a double line. And in addition to that, you say, here, I'm taking this event B and I'm converting it into this event C. Again, this is sort of the abstract way of doing it. But here's how we could take remember the simple server. And the simple server just had the service component in it. It didn't have the arrivals in it. And so the simple server had to listen to an arrival process in order to trigger its arrival events. But now, supposing we wanted to create remember a tandem queue is when you go from one to the next, and we're not worried about the finite blocking or anything. So here's the thing is, remember, a simple server, the end service event was the last event that it had. In other words, the end service event corresponded to a customer leaving that server. And if you remember, when we did the first version of our tandem queue, is we drew an arrow from the first end service to the arrival at the second one. But so what that says is, in other words, what we want is we want an end service at the simple server to trigger an arrival at another simple server. So what do we have here? We have two instances of the simple server, because remember, because there's a parameter, each is parameterized, we can have a different number of servers at each of the stations. We could have a different service times for those. But now this will actually create our tandem queue for us. And what's nice about this is that we've taken two components that we already had without any eye toward this. And by chaining this together, we can create as many of these as we like. So in a way, that's a pretty good bang for the buck. In other words, without a whole lot of work, we now have functionality in a model that goes beyond just having one of these. And what allows us to do it is the adapter, which turns an end service event into an arrival event here. Okay, so now now I want to talk about this next model. And there we have two arrival types, meaning we have two types of customers and only one type of server though. So what might this be? Oh, you know, think of maybe a like a really small supermarket. And in the and again, the analogy is not exact, but remember in supermarkets, you can kind of go in and you can either get a big rolling basket, or you can get a little hand carry basket. And the thing is that because the big baskets can contain a lot more stuff, then in general, if I have a customer who's pushing a cart, on average, they're going to have, it's going to take longer for them to check out than somebody who's just carrying a little hand one. So now it's not a perfect analogy there, but here the idea is that for whatever reason, if I'm a server, then I'm going to prefer one type of customer over another. Okay, and I'm going to have different service times for them. Again, you can sort of think of the basket analogy that kind of breaks down when you push it too far. But this is also a lot of times in certain shops, you'll have big jobs and small jobs, and you might give, for whatever reason, you could give preference to the small jobs because you can get them done and quickly out of the way, or you can give preference to the big jobs because those customers are more important for whatever reason. Okay, but the idea here is that our basic multiple server queue does not capture this. So we want to, we need additional state variables. So the two additional ones now is for our servers, the number of available servers is of course let's see, what is it? Yeah, so our parameters, we have different service times for the, now this is for the type 0 and type 1 customers. And then we just have a certain number of servers. State variables, again, number of available servers because there's only one, but now we're just going to keep track of this is how many type 0 customers are in the queue, and this is how many type 1 customers are in the queue. Okay, so now